Hey, welcome back. Long time no hear from you, see you, all that other good stuff. Um, just so you know, right now we're gonna get back into like factoring and solving equations and all that good stuff, finding zeros and roots of the polynomials. I know we did graphing I don't even know how many weeks ago it feels like. Um, that gets we kind of the big picture of that. We're gonna dive back into dividing and factoring and finding zeros and all that good stuff for a little bit, and then we're gonna come back and make that graphing kind of fit together in that puzzle. Um, I don't know that this is the best order of it, but it's legitimate and it's the way our book does it, and it's the way a lot of other people have tried doing it, and sometimes it gives you a time to digest that previous stuff before we come back to it. All right, so just know we're going to factor polynomials. It should take most of this week. We might even just do that this week. We might get into some of the long ways of doing them by hand a little bit too. But no, we're starting off with the shortcuts. So these are going to be the easiest ones, and we're actually going to do it kind of in the order. Today's factoring binomials, and they're special cases. Mainly two types that we're going to really look at. We're going to look at doing perfect squares, sum and difference, and perfect cubes. But before we get that, we have to really get to know these things. So I'm going to give you a long list of two things. One of them is kind of ridiculous, one of them is not, but you need to know them. Normally, we would just be in the classroom, and I would say, hey, see the posters above in front of the wall? Left side, perfect squares, right side, perfect cubes. We're not in the classroom anymore. So, basically you have to know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. We're going to go up to some big numbers here because we can. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 1,000. You ready? 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196. I love that one. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. Write them down. Use them every single test and quiz as open notes until we get back to school. All right. Those are perfect squares. You don't need to know as many perfect cubes, but there's something I need to show you about them. Perfect cubes, and mainly being able to recognize these are going to be really helpful. You really should write them down and make them as like an index card or a sheet of paper or whatever that you have handy staring at you whenever you're doing work, taking a quiz, taking a test, any of those things. I would expect you to have this list with you as like a reference thing. Alright, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, that's a 3, not a B. 8 cubed is 512, 9 cubed is 729, 10 cubed is 1000, 11 cubed is 1331. I don't know that we need to go too much past that. 12 cubed is 1728. That's far enough. Alright, the big thing I want you to note that's going to be really important is that 1 is on both of those. It's a perfect square and a perfect cube. Right? And then 64 is on both of those. It's also a perfect square and a perfect cube. And I think that's pretty much it. Those are the two sets that are sometimes going to be tricky. When you see 64 and you see 1 as being yourself, remember that they are on the perfect square list and the perfect cube list. That's going to be important to keep track. Keep straight to remember, because that's going to keep you from messing up. By the way, if you didn't write those down, now's a good time to pause, rewind, then pause, and write all those things down again. Remember, this is a video. You have control over it. You can hit pause, you can hit rewind, you can hit fast forward, you can go back, you can reference it. Sometimes I move fast because you can pause, stop it, absorb it, practice what I just did, and then go back and play it. You don't have to go through this in real time. Take some ownership. You control the video. I control what's on the video. You control how fast it plays. Alright. So, I feel fine going fast now. Alright, ready? So first we're going to have perfect squares. Oh, by the way, whenever we're factoring, always, it's easy to forget that. That's going to be every single section on this whole rest of this class. The wind is blowing things into my yard from the neighbors. Great. Every single thing, always, check and see, do they all have something in common? Like, if every single number in your equation or in your expression or whatever is even, take out a 2. Make the numbers smaller. You saw on the list, the numbers can get huge really fast. If you can make the numbers smaller, it's going to make it easier. Just saying. Alright. So, perfect squares. If we have a difference, or we're going to have a sum. Alright? The difference of perfect squares is going to factor to the square root of the first thing plus the square root of the second, and the square root of the first thing minus the square root of the second. Plus or minus, you can do subtraction first and then addition second. It doesn't really matter. The sum of 2 would be the square root of the first thing plus square root of the second. Imaginaries, coming back. Actually, they're never really going away. They're going to start to play a role again. Not a whole lot at first, but just know that it's going to play a bigger and bigger role and become more and more common as we go through this class. First, minus the square root of the second. And again, the plus minus order doesn't matter as long as you have one of each. So, for instance, from that perfect square list, let's say we had 4x squared minus something odd. 49. Right? Perfect square. 4 is a perfect square, and x squared is a perfect square. And 49 is a perfect square. Right? So that would be the square root of 4x squared is 2x. Plus, the square root of 49 is 7. And then I have the exact same thing, this time with different signs. If it was a sum, 4x squared plus 49, still perfect squares, that'd be plus 7i and 2x minus 7i. Yay! Alright, that is a sum or difference of perfect squares. How about if we have perfect cubes? Get ready. This one's new. Perfect squares we did way back when we were in classroom together. Not a lot, but we did do them. We didn't do them a lot because they were coming back. Now we're going to do them a little bit more. Now, perfect cubes, this is like really fun. Uh, the formula is not going to look so fun at first. So if I have a sum, I'm going to put difference over here, changing it up just because it'll be fun. That's going to factor 2. So if I have a perfect cube plus a perfect cube, I'm getting ready to do an example. All right, you're going to have square root cube root of the first plus cube root of the second. Get ready, it's going to get ugly. Times the cube root of the first squared, opposite sign of that, that's plus, so now it's going to be minus. Cube root of the first times the second plus cube root of the second squared. I know that looks really ugly. It's not as ugly as it looks. You can't judge how ugly it is just by the way it looks. Okay, sorry. If it's a difference, we're going to have the cube root of the first minus cube root of the second times cube root of the first squared. I'm going to put the squared there because I'm trying to write it. Opposite sign of that is now plus cube root of the first. I'm writing off the screen times the second plus cube root of the second squared. All right. Again, you have the power to pause. I'm going to just straighten this up. I'm going to show you examples. Because the formula is ugly to write, ugly to think about, ugly to follow. If I talk you through it and you listen, which means your earbuds are now on me and not your favorite song, stay with me. This is not going to be as bad as it first looked formula-wise. The examples are way nicer than the formulas. So let's see, look at my perfect cube list. Let's see, I had 8x cubed, and we'll do a sum first, plus, I don't want to do 729. All right, you look on that perfect cube list that I gave you. 8 is just 2 cubed. 729 is just 9 cubed. Right, so I'm going to start off with saying, both of those guys are on my special list. I'm going to make a set of parentheses that reduces these down to their cube roots. All right, cube root of 8 is just 2. Cube root of x cubed is just x. My plus stays there. 729 is just 9 cubed, so now I've made it smaller. Now I quit looking at this. Oh, by the way, there wasn't anything in common between them. I didn't do that to you yet. Quit looking at that. Now I'm going to look at this. Now I'm going to look at my factored piece. All right? Make a new set of parentheses. I take him and I square him. 2 squared is 4. X squared is x squared. I take this thing and change its sign. I take these two and combine them through multiplication. 2x times 9 is 18x. And I take this guy and square him. 9 squared is 81. Yeah, it's positive. Now what's really cool is this guy right here will almost never factor. It can factor. I can prove that it does, even without going into the imaginary worlds. But I'm going to tell you right now, it's never going to factor pleasantly. That might be a lie, but I don't know it's a lie. Pretty much ends up being something that does not factor nicely at all. It's definitely not going to be anything intuitive, where it's going to be like, ooh, and I'll just do that. So just know, whenever you get here, you're pretty much going to be done. You want to save this towards the end. This is a powerful trick. The sum of 2 perfect cubes is a powerful trick. You want to save it and pull it out at the end of an ugly problem. All right? You've paused, you've looked at it, you've absorbed, you tried it out. Now we're going to do the exact same thing with difference. Let's go different numbers. Let's 64x cubed minus something else that's odd. Ooh, 343. I like using sevens because they're not. People don't usually memorize the sevens as fast, so if I use them, I actually make you think a little bit, which is good. Uh, Usually these numbers, for some reason, become familiar in our heads. Powers of 7 usually don't, even like, ooh, does this number divisible by 7? But they usually make you go back and check your reference stuff, which I like, because when you go check it, and you look at it again, you remember it's there. All right, I look at these and say, huh, these numbers seem familiar. Let me check my sheet. Oh, look, they're both perfect cubes. There's nothing in common between them, so that's good. So I make a set of parentheses, and I take the cube root of both of these. Cube root of 64 is just 4. Cube root of x cubed is just x. Steal my sign. There it is. The cube root of 343 is 7. Now I quit looking at this. I only look at this. Only look at this. Alright. I don't know why I just circled that. I'm getting ready to use this. Alright. Make a new set of parentheses. This guy squared is 16x squared. Ooh, maybe I'll look at it this way. This guy squared is 49. So my first squared is the first thing. My last squared is my last thing. Right? And in the middle, I put them together and change their sign. 4x and 7 makes 28x. And change the sign. And that will technically work whether it's a sum or difference. What that whole pattern I just said, if I steal that sign in here, square the first thing, square the last thing, put them together in the middle, and then change that sign, that right there is how you factor the sum or difference of perfect cubes. Now, we're going to knock out a couple examples just because it'll be fun, just to help you be prepared. They're going to be all mixed up. Who knows what's going to happen? Notice I'm not erasing that check for common terms thing. Oh. How about this guy? In case you can't read my handwriting, it's 375 m cubed minus 648. I grab my little reference sheet of perfect squares, perfect cubes, and say, blast it. They have nothing, they're not on either of the lists. I would not have started off, ooh, hold on, I didn't realize y'all couldn't see that anymore. I would not have started off with a problem that you couldn't do anything with. So, do they have something in common? Well, they're not both even. By the way, I usually check for three numbers are my go-to. 2, 3, and 5. I check them right off the bat. Those are my always checkers. Now, otherwise, if I get stuck, then I'll look for, 7 or 11. But pretty much, if I'm checking prime numbers, 2, 3, 5, 7, 11, 13, 17, I have a list of primes in my classroom. If you look up to the left, you'll see it there. Except you're not in the classroom anymore, so you have to just pretend. But those are the 3 most common guys. If I get really stuck, I go to 7. The reason why I said I like to put in 7s. Alright. Are they divisible by 3? That's 10, that's 15. That's 10, that's 18. Yes, they are. So I'm going to take out a 3. 3 goes in at once, and 25 cubed, almost made a 2, minus twice, and 48, 1, 216. That seems right. Yay! So I know I have to take out a 3. I'm just going to keep that 3 that I took way out on the outside. I just always start off copy him. He's there. Now I look and say, 125 is on the perfect cube list. Should be. There's my cube power. And 216 is also on the cube list, so this is a difference of perfect cubes. Cube root of 125 is 5. Cube root of m cubed is minus, steal my sign, cube root of 216 is 6. Close that parenthesis, start a new one. Go ahead and finish it. first thing squared is 25m squared. I can't write. The last thing squared is positive 36. Those two together become 30m, and change the sign. It was minus, now it's plus 30m. And I'm pretty much done. Yay! Alright, we'll do an ugly one. Oh, this is a classic great one. That's 1x to the 6th. Great. Well, write this down. The same thing times itself is x to the 6th. X cubed times x cubed, which means that x to the 6th is a perfect square. Remember, when you're multiplying, you add exponents. 2 plus 2 plus 2 is also 6. So it's the same thing times itself 3 times, which means x to the 6th is a perfect cube. So 61 is a perfect square and a perfect cube. 64 is a perfect square and a perfect cube. This is a perfect storm. All right? So whenever this happens, always, if possible, look for common terms, take them out first, every single time. If possible, look for perfect squares, then perfect cubes. I cannot write. All right, perfect squares first. Trust me. If we were in the classroom, we'd go through an example, we'd work it out, it'd be awesome. We would waste like a solid 15 minutes checking it out and exploring it. You check it out. Pretend they're perfect cubes. Factor them. Look at it. See when you finish. See how small your answers are. Alright? Then do it with perfect squares. Believe it or not, perfect squares is way better, and you can get it faster without having to worry about it as much. If this is the difference of perfect squares, that means I have x cubed. Square root of 64 is 8. So plus 8. And x cubed minus 8. Alright, now I have a sum of perfect cubes. Okay, notice if I had the difference of perfect cubes the first time, you would have gotten a difference of perfect squares and then an ugly trinomial. You would have taken your difference of perfect squares, factor that, and then you would have had 2 linears and a really ugly trinomial. They even had a large power, and it was difficult to deal with. This guy's going to be a lot more pieces, but you're going to have the good pieces right away. This is a sum of 2 perfect cubes. So, cube root of x cubed is just x. Cube root of 8 is 2. Steal my sign. Set parentheses. Quit looking at this. Look here. First thing squared is x squared. The last thing squared is 4. These two multiplied together is plus 2x. I wrote down plus, changed the sign, now it's subtraction. I've taken care of that one. Now, this is a difference of perfect cubes. So, cube root of the first one is x, cube root of the second one is 2, steal the sign. Then, quit looking at this, look down here. That thing squared is x squared. That thing squared is plus 4. These two multiplied together is negative 2x, and the opposite of that is positive 2x. Now, if you did it the other way, you would have gotten these two pieces, no problem. You would have had what actually is these two things multiplied together. Way not fun. because then you had the two trinomial pieces that were your factors, and it was a trinomial that factors to a product of trinomials. Not enjoyable. All right. You're going to do some other practice problems on the little mirror board. Get in touch with me. Ask me questions. We'll have a talk. They're all going to be perfect. They're all going to be sum or difference of perfect cubes or difference of perfect squares. Don't forget to check for a common term first, because a lot of the problems are going to have something in common there. All right? Good luck. Be safe. Work hard. Thank you.